Execution of Python code with M option or not. The Python interpreter has M module option that runs library module as a script. With this Python code a.py. I tested Python MA to get, whereas Python a.py returns. To me, those two invocations seems to be the same except _package_ is not none when invoked with M option. Interestingly, with Python mrunpy, I get the same as Python MA with Python module compiled to get a.py. What's the practical difference between these invocations? Any pros and cons between them? Also, David Beasley's Python Essential Reference explains it as the M option runs a library module as a script which executes inside the _main_ module prior to the execution of the main script. What does it mean?
When you use the M command line flag, Python will import a module or package for you, then run it as a script. When you don't use the M flag, the file you named is run as just a script. The distinction is important when you try to run a package. There is a big difference between and as in the latter case, foo.bar is imported and relative imports will work correctly with foo.bar as the starting point. Demo. As a result, Python has to actually care about packages when using the M switch. A normal script can never be a package, so _package_ is set to none. But run a package or module inside a package with M and now there is at least the possibility of a package, so the _package_ variable is set to a string value. In the above demonstration it is set to foo.bar, for plain modules not inside a package it is set to an empty string. As for the _main_ module, Python imports scripts being run as it would import regular modules. A new module object is created to hold the global namespace and is stored in sys.modules_main_. This is what the _name_ variable refers to, it is a key in that structure. For packages, you can create an _main_.py module inside and have that run when running Python in package_name, in fact that is the only way you can run a package as a script. So, when naming a package for running with M, Python looks for a _main_ module contained in that package and executes that as a script. Its name is then still set to _main_ and the module object is still stored in sys.modules_main_.
Execution of Python code with M option or not. Use the M flag. The results are pretty much the same when you have a script, but when you develop a package, without the M flag, there's no way to get the imports to work correctly if you want to run a sub-package or module in the package as the main entry point to your program, and believe me, I've tried. The docs. Like the docs on the M flag say. Search sys.path for the named module and execute its contents as the _main_ module. And, as with the C option, the current directory will be added to the start of sys.path. So, is roughly equivalent to. Assuming you don't have a package or script in your current directory called pdb.py. Explanation. Behavior is made deliberately similar to scripts. Many standard library modules contain code that is invoked on their execution as a script. An example is the timeeat module. Some Python code is intended to be run as a module. I think this example is better than the command line option doc example. And from the release note highlights for Python 2.4. The M command line option, Python M module name will find a module in the standard library and invoke it. For example, Python MPDB is equivalent to Python break time equals ones, greater than. Follow-up question. Also, David Beasley's Python Essential reference explains it as the M option runs a library module as a script which executes inside the _main_ module prior to the execution of the main script. It means any module you can look up with an import statement can be run as the entry point of the program, if it has a code block, usually near the end, with if _name _ ==_main _column. M without adding the current directory to the path. A comment here elsewhere says that the M option also adds the current directory to sys.path is obviously a security issue. See preload attack. This behavior is similar to library search order in Windows, before it had been hardened recently. It's a pity that Python does not follow the trend, and does not offer a simple way to disable adding to sys.path. Well, this demonstrates the possible issue. In Windows, remove the quotes. Use the I flag to lock this down for production environments, new in version 3.4. From the docs. I run Python in isolated mode. This also implies E and S. In isolated mode, sys.path contains neither the scripts directory nor the user's site packages directory. All Python environment variables are ignored, too. Further restrictions may be imposed to prevent the user from injecting malicious code. What does _package_ do? It enables explicit relative imports, not particularly germane to this question, though. See this answer here. What's the purpose of the _package_ attribute in Python?
The main reason to run a module, or package, as a script with M is to simplify deployment, especially on Windows. You can install scripts in the same place in the Python library where modules normally go, instead of polluting path or global executable directories such as /.local. The peruser scripts directory is ridiculously hard to find in Windows. Then you just type M and Python finds the script automagically. For example, Python mpip will find the correct pip for the same instance of Python interpreter which executes it. Without M, if user has several Python versions installed, which one would be the global pip? If user prefers classic entry points for command line scripts, these can be easily added as small scripts somewhere in path, or pip can create these at install time with entry _points parameter in setup.py. So just check for _name == _main _ and ignore other non-reliable implementation details.
If you want to see more, please consider subscribing.